Hi everyone, hope you all are doing very well. Today I am going to discuss on some important application level questions on the topic periodic classification of elements. So in my previous video I think I have discussed with you in a very brief manner about the classification of elements and different types of classification, and finally the modern periodic table which we are using now. Okay, so we'll directly go to the question, I think. Okay, so first question is, if we are given, so the question will be like A and B are two elements. Okay, so the name of the elements will not be mentioned, and A and B are two elements with atomic number somewhat like if what 7 and 15. Okay, so 7 and 15 are the atomic number of A and B respectively. Okay, this is the condition for the question. Now the question will be beginning like it will be like sub questions. Okay, A, find the elements. Okay, so we have to find the elements and what? Write the electronic configuration and write the electronic configuration. Okay, so this will be the first question, and second question will be like, so question B will be like, determine the valence. Determine the valency of A and B. So we have to, first we have to determine the elements, and then we have to write the electronic configuration, and next we have to determine the valency of A and B, and third will be like, this is only a model question. Okay, so third question may be like among these two, among them which is smaller and which is larger. So this will be the third question. Okay, so A, B and Z, I think maybe they can come as an essay question, and mark will be divided like 2 marks, 2 marks, 1 marks, or 2 marks, 2 marks and 1 marks. Okay, so this is only a model question. Okay, remember. Now we have to sort it out. So you will be thinking, by just giving the atomic number only, how is it possible to calculate, to identify the elements, write their configuration, and obviously determine whether which is smaller and which is larger among them. Okay, yes, but it is very simple by knowing the atomic number of each element. So before this we have to be very thorough with the periodic table. Okay, so the periodic table will be like hydrogen, helium, lithium, beryllium, and it goes on like this. Okay, so first question was finding out the elements. Okay, so A was 7 and B was 15. So find out the elements. So I have told you that before doing this questions you have to be very thorough with the periodic table. So please students, either you should be thorough with the periodic table, or you should have your periodic table with you while watching this video and doing the problem. Okay, now atomic number 7, which element will be having atomic number 7? Yes, it is nitrogen. So A is nitrogen. Now what is B? The element with atomic number B 15 is phosphorus. Okay, so first question is done. What was the first question? Identify the elements. Yes, we have identified the elements. A is nitrogen and B is phosphorus. Next is what? Writing the electronic configuration of these elements. So electronic configuration, what is electronic configuration? Before this, electronic configuration is the distribution of electrons. Okay, in different orbitals. You might have studied there are shells like K shell, L shell, M shell and N shell. So this will be the nucleus and this will be the orbitals. Okay, this will be the distribution of orbitals. So this will be K, this will be M, this will be M, and this will be N. So these are the distribution of orbitals. So this is the placement of orbitals. Next is the distribution. So K, L, M, N shells. These are the shells. So whenever we have to write the electronic configuration, we distribute the electrons in these orbitals. Okay. So the maximum number of electrons K shell or K orbital can accommodate is 2. 2 is the maximum number of electrons which can be placed in the K shell. Next will be like M, N, L, M and N shells can have 8 shells. Maximum number of 8 electrons in their shells. Okay. So L, M and N shells can accommodate maximum of 8 electrons in them. Okay. Now, so clear about the shells. There are 4 shells K, L, M and N. 2 is the maximum number of shells which can be accommodated or which can be filled in the K shell, and L, M and N shell can have a maximum number of 8 electrons in them. Okay. Now coming to the point, what was our question? Our question was identifying the element and then writing the electronic configuration. So consider first A. What was A here? A was the element nitrogen. So nitrogen atomic number is what? 7, which is given in the question. Here is another point, that is the atomic number. Okay. Every elements will be having equal number of what? Those if 7 is the atomic number of this element, then this element will be having 7 electrons in them. That is, atomic number will be equal to the number of total number. Okay, total number of electrons in them. Clear? So atomic number of an element will be equal to the total number of electrons in them. So what will be the case of nitrogen? Nitrogen will be having an electron, total number of electrons of 7. Why? Because nitrogen atomic number is 7. So 7 is the number of electrons in nitrogen. Okay. Now writing the electronic configuration. 7 is the total number of electrons. So K, L, M and N. What will be the electronic configuration? So I have told you before that in K shell maximum number of electrons which can be filled is 2. So 2 will be filled in K shell. 2 electrons will be filled in K shell. What is remaining? 7 minus 2. 5 is remaining. Okay. So immediately after filling the K shell, we will be going immediately to the next shell, that is L shell. So 2 electrons is filled here. So the remaining is 7 minus 2. 5 electrons are there. These 5 electrons will be filled in the L shell. Okay. So in case of nitrogen, only K and L shell will be used. There is no M and N shells. Okay. So the electronic configuration will be 2, 5. 2, 5 was the electronic configuration of nitrogen. Next is what? Next was phosphorus. Phosphorus is what? 15. 15 was the atomic number as given in the question. So what will be the total number of electrons? 15 will be the total number of electrons in phosphorus. Okay. Same way K, L, M, N. Okay. Now, as above, K will be always having a capacity of accommodating 2 electrons. So in K shell there will always be 2 electrons only, and in all the other shell there will be 8 electrons filled. So 2 is filled in the K shell. So 15 minus 2, 13 are remaining. Okay. Now, what was the maximum number of electrons which can be filled in L shell? 8, right? So 8 will be filled in L shell. So 8 plus 2, 10. 10 electrons have been filled in K and L shell. What is, how many electrons are remaining? 10, 15 minus 10. So 5 electrons are remaining to be filled. Those 5 electrons will be filled automatically in the next level or next orbital. Okay. So 285. So the electronic configuration of phosphorus is 285. Okay. This is the electronic configuration. First question have been cleared. What was the first question? Identifying the elements and then writing the electronic configuration of this element. So we have cleared the question A. Next is the question B. So the second question was finding the valency. What was it? Finding the valency. Before that, we have to know what is this valency. What does this term valency means? Okay. Valency means, before that we have to know about valence electrons. What is valence electron? So, in case of nitrogen, take nitrogen. What was the electronic configuration? 2, 5. So, this is the K shell, this is the L shell. Here in nitrogen, this shell is the outermost shell, right? This is the outermost shell and this is the innermost shell. So, in nitrogen, in case of nitrogen, KL, L shell is the outermost shell. So, valence electron is the number of electrons which are present in the outermost shell. Okay. Now, valence electron. So, what will be the number of valence electrons in nitrogen? Obviously, it will be 5 because there are only 5 electrons in the outermost shell. Now, tell me what will be the number of electrons in phosphorus, because as previously we have written the electronic configuration as 2, 8, 5. Okay. So, what will be the valence electrons? Yes, same as nitrogen. The number of electrons. So, here KL only, here it is KLM. So, M is the outermost shell in case of phosphorus. Okay. So, M is the outermost shell and it is having 5 electrons. So, in case of phosphorus, 5 is the valence electrons. Okay. Clear about what is the valence electrons? Valence electrons are the number of electrons which are present in the outermost shell. Okay. Now coming to the point of valency. Valency is termed as the number of electrons which are gained or lost during when they attain a octet. Okay, what is octet? Before that, octet is a state which an orbital or a shell attains when it have 8 electrons or a completely filled electrons. When is these L, M, N, etc. shells will be fulfilled? These are only filled when they have 8 electrons. Okay, the maximum number of electrons accumulated by these L, M, N shells are 8. So, this attaining, when they attain 8 electrons maximum, that is when they are completely filled, they attain a state of octet. Okay, at this octet they are very stable, they attain stability when they have maximum number of 8 electrons. When they are filled with 8 electrons, they are completely filled with maximum number of 8 electrons and they attain octet. Okay. So, coming to the point of valency, valency is the number of electrons which are gained or lost during when they attain octet or during when they attain stability. Okay. So, now nitrogen, considering nitrogen, the electronic configuration is 2, 5. Okay. So, this is K, this is L. In L shell, we have told you that the maximum number of electrons which can be filled is 8. So, either these 5 electrons should be removed so that 2 will be the outermost shell, and K will be the outermost shell, and it will be filled completely with maximum number of 2 electrons, which is the maximum capacity of K shell. So, K shell is only able to accommodate 2 electrons, and it is having those 2 electrons, that is it is completely filled. So, in order to attain a stability, either this 5 electrons should be removed, so that what? If these 5 electrons are removed, then 2 will be the outermost shell and K shell is completely filled. So, they will be attaining a stability. Either this 5 electrons should be removed, or what? Again a 3 electrons should be taken to this orbital, so that 5 plus 3 it will be 8, okay, which will be more easier, either giving 5 electrons out or taking out 3 electrons, which will be requiring more energy. Exactly. Attaining or giving out 5 electrons will be causing more loss of energy, okay, because the number of electrons, there are 5 electrons to be removed, okay. In another hand, the only 3 electrons is needed to be taken in. So, obviously, we will be preferring of taking 3 electrons, so that only less energy will be consumed, okay. Similarly, in case of orbitals also, they will be preferring more chance of taking 3 electrons to them, so that they can attain a stability, okay. So, that 8 electrons, say the L shell will be completely filled. So, 3 electrons are to be taken in, okay. So, when 3 electrons, 3 negative charge, okay, electrons are having negative charge. So, when 3 electrons are taken in, L shell will be obtaining an octet, and 2,8 will be the octet state of nitrogen. So, 3 electrons are taken. So, the valency will be, what did I say about valency? Valency is the number of electrons lost or gained. Lost or gained during when they attain octet or when they attain stability. So, 3 is the valency. Since 3 electrons, 3 negatively charged electrons are taken in extra, the valency will be -3. Okay. Next, about phosphorus. Phosphorus, what was the electronic configuration? It is 2, 8, 5, right? So, this is K shell, this is M shell, and this is M shell. Similarly, here also 5 is the outermost, M is the outer, no, here it was L was the outermost shell, here M is the outermost shell, but the number of electrons in both the cases, outermost shell, are similar, right, 5 and 5. So, in the above case, 3 electrons will be taken in, because it will be consuming only less energy. So, 3 electrons will be taken. So, the valency will be like what? -3. If suppose the element was not phosphorus, then if suppose, this is just an example to make you it very clear, okay. If it was 2, 8, 3, then what? Then what happens? 2, 8, 3. 3 is the valence electrons present in this particular, naming it as C, for example, or Q. 2, 8, 3 is the electronic configuration, and 3 is the outermost electrons present in the outermost shell. So, what will be the case? Either they should take 5 electrons, or they should give up 3 electrons out, so that this orbital will be removed, and what will be the configuration? 2, 8, which is a stable configuration, right. So, here in this case only 3 electrons are to be given out, but if either only 3 electrons should be given out, or 5 electrons must be taken in. So, in such cases they will be always preferring 3 electrons to be given out, because only less energy, okay, the number of electrons will be low and the number of energy consumed will also be low, okay. So, 3 electrons will be given out and the configuration will be 2, 8, okay. So, second question is also clear, right. The third question is about among these two elements, which is smaller and which is larger. So, the electronic configuration of nitrogen is 2, 5 and phosphorus is 2, 8, 5. Before discussing on this, just have a look on the periodic table, okay. And see Where is phosphorus and nitrogen placed in the periodic table? Okay, nitrogen and phosphorus are placed in the same group, right? In the 15th group. Okay, so nitrogen is placed in the upper period, and phosphorus is placed just below the nitrogen's period. Okay, so nitrogen is placed in the second period and phosphorus is placed in the third period. That is, the table will be like this: nitrogen, phosphorus, this is the 15th group, this is the second, and this is the third. Okay, nitrogen is placed in the second period and phosphorus is placed in the third period. Okay, so group will be same but the period differs, right? Next, now the electronic configuration of nitrogen is 2,5. So this is the nucleus, this is the K shell, this is the L shell. So this is K shell, this is L shell. Now representing the electrons. In K there are 2 electrons. In L shell there are 5 electrons, right? 1, 2, 3, 4, 5. Okay. Similarly, in case of phosphorus, this is the nucleus, this is K, this is L, and this is M, right? So the electronic configuration distribution will be like 2 here in the K shell, right, and 8 in the L shell. 1, 2, 3, 4, 5, 6, 7, 8, right? In the M shell, 1, 2, 3, 4, 5. Okay, this is the electron distribution. Now, so which is the much more larger and much more smaller elements? About this was a question, right? Now considering N, nitrogen, 7 is the atomic number and here 15 is the atomic number. Okay, so this is the nucleus. So nucleus will be having a charge of what? This will be having a positive charge, and this positive charge will be attracting the electrons towards itself, because since electrons are negatively charged and nucleus is positively charged, there will be an attraction between this nucleus and electrons. So this nucleus will be attracting these electrons towards itself, right? But here also nucleus is there. Okay, so here there are only 2 orbitals. So the nucleus charge will be attracting them. Only 2 orbitals are there, so it will be very much convenient in order to attract these electrons towards itself. Only 2 orbitals and only totally 7 electrons are there, so it will be very easy. But in case of phosphorus, there are 3 orbitals, that is the number of orbitals are increasing. As the number of orbitals increases, the nucleus will be having a positive charge, and this positive charge nucleus will be attracting the electrons towards itself. But the difference is that since the number of orbitals are increasing, here it is KL but here it is KLM. So the number of orbitals are increasing, so this nuclear charge will not be enough for attracting all these electrons towards itself. You got the point? This nuclear charge will not be having enough positive charge for attracting all the electrons in the till here the nucleus charge won't be reaching. Okay, so it won't be able to attract properly or attract tightly the outermost electrons. So this will be loosely binded. Since here the attraction is very stronger, this orbital will be coming close to this nucleus, and this what happens, as this electrons and the orbitals come closer to the nucleus, the size of this atom or the size of this element also what decreases. Okay, but here the nuclear charge will not be having enough positive charge for attracting until what, the outermost electron. So there won't be much attraction as compared to this, so this will be little bit larger than this. Got the point? So what, which will be smaller? Obviously this nitrogen will be smaller and phosphorus will be larger by comparing both these. Okay, what was the question? Among this, nitrogen is smaller and phosphorus is larger. Why? Because this is the reason. As the number of shells increases, the nuclear charge will not be having enough positive charge for attracting the electrons of outermost shell. Thus, the size will be increasing, which leads to the increasing of the element, increasing size of the element. So, phosphorus will be larger. From this point, so nitrogen, phosphorus. So, this is along a group. So, from this a point is obtained that along a group, what? The atomic size. What happens to the atomic size? Atomic size increases as we move down to the group. Okay, it was an application question in the chapter periodic classification of elements, but if still there are some doubts, then you can just let me know by commenting in the comment box. And also, if you want me to take any topics based on chemistry, then you can just let me know by commenting in the box. Thank you so much for watching my videos.